Algebra 1 skills number 45. Again, looking at geometric sequence. This time the recursive formula. Okay, so the recursive formula simply tells you how to get from the next term from a given position. It doesn't care where you start or where you are even. It only cares about how to get to the next position. So understand the role of the recursive formula. A sub n is the current term, just like it would be in the explicit formula. And then a sub n minus 1. When you see a sub, so sub for subscript, n minus 1, you know you're dealing with the recursive formula. It stands for the previous term. And then this is your recursive formula, or the recursive formula look for a geometric sequence. It's the previous term times r. So our first example, write the recursive formula given the following information. So a sub 1 is 5 and r is negative 2. So here's the recursive formula. Notice it doesn't care what a sub 1 is, so there's no need to have the 5. You just simply put the negative 2 in the r position, and that's it. So this, again, it's not as powerful as the explicit formula. It just tells you how to get to the next term from where you are. Okay, a second example, write the first 5 terms of the geometric sequence in the situation where you're given, again, this recursive look, because we recognize a sub n minus 1, and you're told that you begin at 5. So this is your sequence. We need to know, to write the first 5 terms, we have to be given some sort of position, and we're given that first position. And you just simply multiply negative 2 each time. So 5 to negative 10 to 20 to negative 40 to 80. Notice again the pattern there, you're alternating positive negative because of the negative r. Notice also that with the recursive formula, I have no way to directly go to a certain position like you would with the explicit formula. So if I want to go directly to term 5, I would have to go through terms 2, 3, and 4, unlike the explicit formula where I could just simply plug the 5 into it. Here it just goes from one term to the next. That's its purpose. A third example says, given the recursive formula, write the explicit formula. I actually need a little more than the recursive formula. I need to know a sub 1 as well. Okay. So here's the given information, and here is the explicit formula. Notice the explicit formula requires a sub 1 and r. Okay, n would be, if you're given a position, you could use it, but if you're just writing the explicit formula, you don't actually need to know an exact n. Well, a sub 1 is given directly as 3, and we need to be able to look at this and tell that, okay, this is recursive because we have a sub n minus 1, and that the number in front of that would be the r value. So my explicit formula in this case would be 3 for a sub 1 given directly, and 1/2 that you took from the recursive formula. Okay, so this is the explicit equivalent to this information. That is geometric sequences and the recursive formula.